So for this video, we're going to take a look at the Project 2 requirements, and I'm going to show you how to use Desmos and the rest to work through it. Of course, hopefully you're catching this stuff through the Unit 2 material as well. So just as a reminder, all the project information is located in this Project Documents folder. You're going to need the Project 2 data for one task and the Unit 2 project for the other, the description of it. So this project has 5 tasks. Five tasks attached to it. And as the same disclaimer as before, this is you showing that you understand the Unit 2 material. So this project should be unique to you. Feel free to ask me questions, work with your classmates, tutors, other instructors, etc. But make sure what you submit is your work and not identical to someone else's. That would be considered lacking academic integrity. Okay, so the first project, or the first thing you're going to do is collect some data from the stock market. So you're going to pick a stock that you like. Here's some examples. I'm a big fan of Yahoo Finance as a place to look at stock tickers. So I've clicked that link in the digital version. Here's Yahoo. And I'm just going to find a stock that is interesting to me. You may have heard of GameStop. Its symbol is GME, and it went really high because of some Reddit stuff. So here it is. Hey, look, it went up today by $1.30, up 2.54%. So this is a stock table, and it's got a whole bunch of information that we're going to look at in Unit 3. What I'm asking for you to do is pick either the previous close or the open value, and you're going to record that for 10 days worth of data. Now, if you read what the project says, it says record the opening value. I'm okay if you use closing value. I'll just type in here closing value of the stock for 2 weeks. Now, the market is only open, actively open for trading on a business day, so Monday through Friday. So when I say 2 weeks, I'm saying that you need 10 days worth of data. There is an exception to this. In some of my other classes, we've been talking about Bitcoin. This is another Reddit Bitcoin. I guess it's called Doge. Oh, it's down. I bought some of this the other day for $1.34, and I've lost a couple cents. At any rate, what are these called? Cryptocurrencies. These are not stocks, and they are traded 24/7. So if you want to follow a cryptocurrency, the more famous one, of course, is Bitcoin, which is just going nuts right now. Tesla's investing in it. Big bankers are investing in it. Look at that, $48,000 for one Bitcoin. If we look at the 5-year thing, look at that. Back in 2017, it was worth $1,000 for one Bitcoin, and now it's crazy high. So you could be billionaires if you bought a bunch of Bitcoin back then. At any rate, these things are traded just 24 hours, nonstop. They're not a stock. They're not really regulated right now. So if you're going to do that, you could get your 10 days worth of data in exactly 10 days. What you would have to decide on is there's really no such thing as a previous close and open per se. I'm not quite sure how they're tracking this. At any rate, your goal is to get 10 days worth of data. So you might want to record these data in an Excel spreadsheet. So I think what would be a good idea is to say something like date, day, and then value. And you might want to note, just for your own sake or for my sake, what you chose. So I'm going to say I chose opening value. Let me make these a little bigger. And of course, you can double click in between to autofill, but we're going to want these a little bit bigger. So let's pretend I picked today as my starting day, Monday, and then we'll do five days here. Actually, let's just do a whole 10 days. There we go. There's 10 days worth of data. I think what I want to say here, date and then day, what you're going to discover in the project or in the Unit 2 stuff is that you're going to pick a starting value. So we'll say that February 15 for me is day 0. And then every day after this would be one day after that first day. So you can see this would be, 5, 6, 7, 8. Oh boy, look at me messing up like crazy. 8 and then 9. Now, if you're recording weekends like I have in here, the 20th is a Saturday and the 21st is a Sunday. There's not going to be a value traded here, so you may have to leave that alone. So I'm just going to make up some values here, and then I'll walk you through what we can do. So let's say it was 1356, and then 1487, and then, I know, big jump, 1987, and then 5698, and then 75, exactly, whatever, 200, 256, 387, and then the market crashed out 100 and back down to $2. Okay, so this would be what your data could look like. You can clean things up, do all these borders, whatever. I'm not worried about how it looks, just as long as it's readable. And then your job is to figure out, so that's our table with the date and then the opening value, and we got x equals 0 for the first day we started recording. And we've got 10 days of data. So then what you're demonstrating in this project is that you understand how to tell if something looks linear or something looks exponential. So you're determining the model of best fit between those two. And we're going to explain our choice using the graph and the correlation coefficient, etc. And then whichever one we pick, you're going to talk about the parameters. So if it's linear, it's M and B. If it's exponential, it's A and B. You'll know what that means as you work through Unit 2. You're going to interpret those in context, and then we're going to make a prediction, and then we're going to look at how good was our prediction. Now, mine's going to be terrible. So if we're using Excel, we would select our data values, not the date, but the X's. So maybe I should put in here that we're letting the days represent X. And we're going to insert a line graph. Wrong again. Where is it? We're going to insert a scatter plot. Here we go. So here's my scatter plot. That does not look linear, nor does it look exponential because of these two data points. If it had been this, that would have been exponential. Now, if we want Excel to give us the equation, you pick this one that gives us the f of x, and Excel gives you that equation. That's the linear one, and then there's an exponential one. But I think Excel is not the greatest way to do this. To find the exponential is a little bit difficult, and it doesn't give you the r value, it gives the r squared value. Come on now. So let's do this in Desmos. Now, to do this in Desmos, we do have to hand type those values, which is unfortunate, but whatever. So go to Desmos, we're going to start graphing, we're going to put in a table, and let's just see, maybe I'm wrong, maybe it'll take these. Let me try again. Nope, doesn't like it. Doesn't matter for the x's, just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then for my y's, I'm going to have to type this mess in. So I got my values typed in, and it's difficult to see the scatter plot. We can see one point right here, the 9, 2 point, but we want to see all of it. So I'm going to click this zoom fit, and there's the same picture Excel gave us. And then you're going to learn this in the unit. To get the linear regression equation, you just type in y1 tilde mx plus b. If we want the exponential one, you type in y1 tilde ab raised to the x1. And we want log mode for this to give us the r value, and log mode matches what you'd use in a TI-84. So neither of these are very good models. If I had to, since you are forced to pick between the two, the best model is this one, the linear one, because the r value is the closest to 1. But that's a very weak correlation there. And then here's the parameters. Note, Desmos talks about it as a parameter. So this is what you would do, and then you'd be filling out in context what this M and B represents. What might be a little tricky is making sure you get this graph into either Excel or Word or some digital format for that. So one way to do that is we can go into Excel and say we want that Desmos one and we want to keep this table. Just go to the Insert button, and there's this screen clipping option right here, Screenshot. So I'm going to take a screen clipping, and you have to have the Desmos screen as the default thing open, and then you can drag your that screen clipping thing, and bam, there's a nice picture of the graph. If we want to resize it, make it a little smaller, we can. You could even label these graphs, these things in Desmos, if we wanted to. Under the wrench, you could add a label for the x-axis. This would be days since 215, and then the y-axis, this is value, and this was GME. So now we've got the axes in there. So let me insert that again. I'm going to delete this one I had and insert. We're going to do screen clipping. And then there it is. Now Word will do the same thing. So if you'd rather do all this in Word, same place, you go to Insert and Screen Clipping. Oops, not the one we want. Oh, I got it just in time. And then we might want, well, so you're supposed to include the R values in your talk. So you could do this whole thing and then type up the values, or you could just show the graph and then write up what this all is. So that's task 1. Now task 2, you're getting a set of data provided to you from the federal outlays data. So I went to a government website and I downloaded this set of data, and this is dollars in millions. So the legislative branch back in 1962 had $196 million that they were budgeted to spend, I believe, is how that looks out. So I'm asking each person to randomly generate a set of data from that. So how do we do it? We using the randomly generated year assigned to you for your starting year, pick every third year from the starting year and generate a data set of 10 values. So I will have to post that year for each person. It'll be randomly created, and you're going to pick one of these things that are of interest to you. So you could look at a specific line item, like maybe you're really interested in the legislative branch, or you could say, I'm really interested in how much off budget we were or how much on budget we were. Or you're interested in the total money that was spent, the total outlays by the federal government. Pick any one of these, doesn't matter which, just make sure you tell me which one you chose. And if you started with 1963 as your first year, you're going to do every third year from that. So I will generate this as if I was doing 1962 in Desmos. I'm going to create a new table, and I would just start typing these in. So 0 for me corresponds to 1963. You might want to first put this in Excel so that we know what the value is that you started with. So 1963, 3 years later would be 1966. That would be a 3 because we're doing years since 1963. That's 234. So I know that this is going to be 6, 9, 12, 15, 18, 21. Is that enough? 1, 2, 3, 4, 5, 6, 7, 8. I need one more. 9, 10. 2 more. Okay, so let's see. I did 3 years, and then 1969 would be the next one. So that's 289. And then after that, 1972, 3 years later, 499. Oh, went too far. I'm going to pause this. Okay, so I went through and got my data. Now, since I have my other graph on here, I'm going to hide this, and I'm going to hide these other equations that I have in here. Shoop, turn those off. And I want to get a picture of this data set. There it is. So that to me looks fairly exponential, but it could also be linear. So let me type in the equations. Now notice I've got an x3 and a y3. So I need y3 tilde, come on now, tilde mx3 plus B. By the way, if you're wondering where that tilde button is, in Desmos's keyboard, it's right here. On your actual keyboard, it would be shift the thing next to 1, and that'll get you the tilde key. Okay, let's put in, that was the linear, let's put in the exponential one, and then we can compare them. Oh, I got that as an expression, my bad. We need, I guess I could just hit enter. So y3 tilde ab to the x3. And now we compare the two. The linear one is 0.997. The exponential one is 0.968. So the exponential one is the better model. So it's the exact same thing for this one as you did for your stock stuff. You generate your scatter plot, you determine a model best fit, you explain what you chose, hint, use your correlation coefficient. You can also look at the graph. And then you're to identify the two parameters and interpret them. So there'll be 2 sentences here. And then you use your model to predict the amount for 2019. Now, my value was 1963. So the X value I would use is 2019 minus 1963, whatever that number is. That's going to be the value I plug in for X. Notice you're then going to calculate the actual and relative difference between what we predicted and what we got, what it actually is in 2019. Notice that our table gives us the value for 2019, and I believe it's an actual value, so it should be 4,961. All right, the third task is just come up with your own data set. You can go search online. Wikipedia has tons of data sets. Maybe you want to look at, say, the number of games it took to win a World Series or an NBA final. You could look at the number of home runs hit each year in the baseball season. That's sports stuff. I mean, there's tons of sports stuff. You could look at the sales of marijuana per year since it was legalized in a particular state. Now, Michigan, we just legalized it in, 2018, so you won't be able to get a big data set, although maybe you could do it monthly. Anything you want. Your job is to note what the X and Y values are. So you're going to describe what the data set is that you found and note what is your independent variable and your dependent variable. And then you're going to create a model. Again, the only 2 models we're working with in this course is linear or exponential. There's tons of other models out there that are far more complicated and used to predict things. Many of them you might need some differential equations, which is after you take Calc 1, 2, and 3. And then you make some sort of prediction with it. Maybe you want to use your data for how much time you spent back in your Unit 1 on a particular thing, your Unit 1 project. So then the fourth task is just to kind of talk about, hey, what do you see are strengths and weaknesses of a linear model, strengths and weaknesses of an exponential model? Why do you think scientists use these models? That should be an S, my goodness, these typos. And then what other model types exist and how might they be useful? Just, there's not a whole lot of wrong answers to this, just well thought out or poorly thought out answers. Don't spend hours and hours and paragraphs. A couple sentences is fine here. I just want to see that you're engaging with this material and demonstrate that you kind of understand what's happening with them. And then the final task here is to scale a recipe. So you're going to find a recipe for a cookbook or from a cookbook, and you're going to scale it. So let me just demonstrate this. Am I vegetarian? What? I know. I was raised that way, so it's not like I have some sort of philosophical reason to be it. So here's a no, that's not that. Okay, here's the top 20 vegetarian dinner recipes. My wife always complains about how these recipe things, there's like a mile of typing, and then the recipe is way down at the bottom. And of course, the reason is, see all these ads popping up? That's how the person who wrote this makes money. All right, so we got to find a recipe. Oh, here we go. Mushroom Wellington with rosemary. This is nice. Jump to the recipe. So this is the information you're looking for right here. We want the yield, 8 to 10 servings. So you're going to have to pick one of those numbers, either 8, 9, or 10, and that is going to be the number of people it will serve. So you have to fix one of those numbers, or you could do all three. It's up to you. And then your job is to take all of these and scale them up, all of these ingredients. You're to scale to a serving of one person. I'm sorry, that's scaled down. So you're going to rewrite the recipe to scale down. And then for B, you're going to rewrite the recipe to serve 100 people. You can do this using percentages or fractions. It's really tying back into what you did in Unit 1. I believe it's 1.6 is the lesson that we went through this. Note that you don't want to pick a complicated recipe that has thousands of things that you have to scale with, right? Pick a fairly simple thing that only has a couple ingredients in it to save yourself some time. And that's it for the projects. If you have questions, please send them to me. I think what I've given you is all that you need to do the software side of things. So you should be able to create these models in Desmos. You're going to see a lot of this throughout the Unit 2 videos from 2.4 on. You should be able to pick your stock and record the data for that. And then you should also be able to pick your data from the federal outlays table. Beyond that, I guess the only other skill you need is being able to insert this screenshots into a document of some sort. So I'll do a screenshot of that recipe one last time. Just as a reminder, you need to have the thing open that you want to take a screenshot of. So here it is open. And then I go into Word, I click screenshot from the insert menu, and you want screen clipping. And then it hides, and whatever was the last thing was open is what you can then clip from. And here's what I want to clip is this part. So there's the screenshot of my recipe with the pertinent information. All right, good luck with it all, and please ask as many questions you have. Send them by email or show up to my office hours or request a time to meet if my office hours don't work.